Today with our calculator review, I want to review how to graph functions. Okay, so in order to graph functions, obviously turn your calculator on to start with. We're going to go to y equals. Okay, now let's start with a basic linear function. I'm going to say 2x plus 3. Okay, all you got to do is type it in just like I did. If we want to graph it, we're going to hit the graph button. Now, most of you, if you've not played with your settings at all, are going to have this graph on the standard view so it looks like this. Okay, I encourage, especially for basic functions, and a lot of the functions you're tested on are going to be pretty basic. If you're wondering about your graphical zone, the standard zoom is an excellent place to start. So if you wind up going and your graph looks wonky or you can't see anything on your graph, the first thing I'm going to tell you to do zoom wise in order to be able to see it is hit zoom and then come down here to zoom standard. Zoom standard is going to give you the 10 by 10 window to view your graph on, and it captures a lot of the basic graphs that most of your classes will go over. It doesn't capture all of them obviously, but it will capture a lot of your basic graphs. A lot of your basic graphs that we study are in that 10 by 10 window. Obviously we can get much more complicated and get outside that 10 by 10 window, which you will see in your college mathematics. Okay, so graph the basic function. Now, if we did want to adjust our zoom to see something else, we could zoom in. If we wanted to zoom in on a certain section of the graph, we would go to that graph, say we want to zoom in here on our y-intercept. So I can go where this y-intercept looks like it hits with my cursor. If I hit enter a few times, you can see it zooms closer and closer to it. It zooms to center wherever your cursor's at. So if I move it back over here, it's going to recenter it where that cursor's at when I hit enter on the zoom in. Zoom out works the same way. I hit the zoom button, I go to zoom out, and I can just hit enter, and it continues to zoom out for me. If I want to recenter it, I can. Say I want to recenter it over here, I can do that. You can see it recenters it over to that direction. To bring it back to the 10 by 10 standard window, I can just hit the zoom button and go to zoom standard, and I'm back to my 10 by 10 window. Okay. Another favorite of students is the zoom, and if you keep scrolling all the way down, the zoom fit. A lot of students like to use the zoom fit option. If you use the zoom fit option, it tries to fit the graph how the calculator thinks gives the best picture. Sometimes it works well, sometimes not so much, but the one good thing about zoom fit is it always gets at least a piece of your line within the screen. Okay, because sometimes when you graph a line, even on zoom standard, you won't even see the line at all within your screen. Zoom fit will at least put your line on your screen. Okay, then you can zoom in and out as necessary to see what you want to see. Okay, so there are kind of your zoom options. The other zoom option we do use sometimes when we plot points is zoom stat. If you plot points and you're doing regressions, zoom stat can be especially helpful. It does a great job. But for now, we'll stick with the zoom in, the zoom out, the zoom standard, and the zoom fit. Those four will really, really help you in your graphical interface. Okay. Now, once you have your graph done and you have it zoomed how you want it zoomed, I'm going to go back to zoom standard. Just keep it on that 10 by 10 window. If you look at your window button next to your zoom, it'll tell you what your window is. Obviously, like I said, the standard window is the 10 by 10. You can adjust these numbers however you want to. You can type in if you want your x-min to be, say, 100 instead of negative 100 instead of negative 10. You could do that. So if I want the window to be 100 by 100, I can go negative 100 to positive 100 on my x, and negative 100 to positive 100 on my y to adjust my graphical view here. Oops, too many zeros. And then I can graph, and you can see it zooms it way out. So I now have a 100 by 100 window rather than a 10 by 10 window. Okay, gonna bring it right back into standard. Sometimes problems will give you the window they want you to view it on, so the window interface place allows you to adjust your X min, your X max, your Y min, your Y max based upon that viewing window that some programs will give you. Okay, so back on the standard viewing window here, the 10 by 10. If you wanted to hit the trace button allows you to hit the cursors left, right, up, down, whatever. Most of the time it works left, right. And basically any numbers that come up with the X and Y are numbers that are on this line. Okay, that can be helpful sometimes. I don't use the trace option very often, but you can obviously see your y-intercept here is 0, 3. But the trace function here does allow you to trace your entire line to look for points on your line. It's not overly efficient, but what it can allow for is while you're tracing. So like I said, if you hit the trace button, let's say we want to know exactly what our y is at -2. I can hit -2 while I'm tracing, and it will take me there. Okay, so if I say, okay, x is -2, y is -1 on this particular line, at say x is 0, y is 3 on this line. Okay, so that's kind of a benefit of your trace function if you're trying to find a particular point on that specific line. Okay, now let's look at some of these blue functions that we have, specifically the second trace or second calc option. The second calc option to me is especially useful because it allows you to find quite a few things here. Okay, if you see you have a few options under the calculate menu here, value, 0, minimum, maximum, intersect, and you can even find derivatives and interval here. I won't mess with 6 and 7, but I will look at 1 through 5, the value through the intersect. Okay, if you do want to calculate a value, kind of like what we were doing with trace anyway, you can do that. You just type x equals, say 1, and it tells you, okay, your corresponding y value here is 5. Okay, that can be especially helpful. Like I said, you can also do that same thing through the trace function. It's the number 1 response on it. So there you go. When x is 6, y is 15. Okay, if I go back to second calc, another benefit of it is what we call zeros here. Okay, zeros is where it crosses the x-axis. Now, when you're finding a 0 and you select that 0 option, so just so you know, I did second calc 0, number 2, and hit enter. Okay, it's going to ask you, it's going to say left bound question mark. Okay, our zeros are where it crosses the x-axis here. Left bound just means you want to go to the left of where you think it crosses the x-axis. So I'm to the left of where I think it crosses the x-axis. I hit enter. I also want to go right bound of where I think it crosses that x-axis. I'm going to hit enter. And then it wants you to guess where you think it crosses that x-axis. I'm going to guess about right here. I'm going to hit enter. And then after that last enter, it finds your 0 of -1.5, 0. Okay, so -1.5 for your x, 0 for your y, and we have found our 0 for this particular function. Okay, that's beneficial because you can find your y values and stuff given a certain x here with that trace function or that value function, but zeros you can't necessarily find without running the 0 function or without hand calculating it on a piece of paper. Okay, so we can find our zeros with our calculator. Let's look at the next option. Now the next option says minimum, maximum, and then intersect. Okay. Now with a linear function, you're not going to have a min and max, so to speak, to be able to find. So let's look at a squared function here. Okay, so x squared, we'll say +2. Okay, if I graph that, you can see here we have a minimum. Well, let's say we want to know what that minimum is. We can do second calc minimum. Okay, and it's going to ask you the same thing it did with the other function. It wants you to go left bound of that minimum, hit enter. It wants you to go right bound of that minimum, hit enter, and then it wants you to find that minimum, hit enter. Okay, now the weird thing that the calculator does do here sometimes is it gives you some weird x and y values when you do min and max. If we look at this x value, it's -8.284 e to the -8, which means we move our decimal place 8 places to the left. Okay, so this is technically 0.00000008. Okay, sometimes when it's doing this calculation to find the minimum and it's running this function or this program it does to find it, it doesn't get it exact. Here, the minimum is 0.2. Okay, so if you get a really weird e to a large negative number, it's probably trying to tell you that that number is supposed to be 0. Okay, so that is our minimum. We do the same thing for maximum, but you do need to have a maximum function for it. So we'll do negative 2x squared plus 2. If we look at this function, we now see we have a maximum here. We can calculate that as well. So second calc, scroll down to maximum. We'll go left bound on it. We'll go right bound on it. And then we will go to the center and guess what the top part is. And like I said, it does the weird e to the negative here for me as well. So it's got 1.46 e to the negative 6. It's essentially meaning 0.2. Okay. So if we move the decimal place 6 places left, we essentially have a 0 if we round. So we're looking at 0.2 as our maximum point. Okay. The other thing underneath this second calc trace function here is intersect. Okay. So sometimes we do want to see when two things intersect. So let's keep this function and then let's look at 4x minus 3. Okay. So we can clearly see that these two functions intersect. Technically, if I use my zoom out option here, we can see they intersect in two locations. Okay. So if I do second calc intersect, it's going to say which is the first curve that you're looking at. Okay. So I'm going to hit enter on the blue curve, and then I'm going to hit enter on the red curve as my second curve that I'm looking at. Then it wants you to guess where they intersect. Okay. This guess part is important, especially when you have multiple intersections happening, because you want it close to the intersection that you care about. Okay. So I'm going to go to that top intersection first, and it finds it for us. Now, if you want to find out what the other intersecting point is, you're going to have to run the function completely over again. Okay. So second calc intersect. Okay. First curve, second curve. You can basically hit enter twice, and then scroll down here and guess where that second intersection is. Hit enter again, and it finds that one for you as well. So here I'm looking at negative 2.87 to negative 14.48 for your y. So we are able to find both intersection points here. Okay. So like I said, a lot of interesting things when it comes to graphing. We can certainly do some more. If you're taking a stat style class, it might be important for you to actually be able to use some of these statistical plots. I'm not going to go through all of them, but I will show you that they're here. Okay, this is your number one right here is your typical scatter plot. Then you have a line graph here. This is a histogram. You have your box plot or box and whisker plots. And then you have another one over here at the very far right. I think that's your normal quantile table right there. Okay, you can change some stuff up, the X list, Y list that you pull through. You can turn your plots on and off. I'm going to leave them off because I'm not really messing with plots right now. The other thing that some students find beneficial, let me type in a new function here. Okay, the other things that some people find, or some students find beneficial, is your table function. So if I go second table, okay, it gives me a list of x, y values here. Okay, so it calculates them out for me. I can use my little tab here to scroll up and down to look at the different x values and the corresponding y values here. You can look at the graph after you graph it. If I did a zoom standard on that one, there you go. If I look at the graph here, that's what it looks like. If I look at the table, I can tell what these corresponding values are without having to trace or go up and down the table looking for values with the second calc. Okay. Sometimes the values will come straight out in the table, like your mins and maxes. Sometimes you can see them in your table. Other times, it's best to actually go ahead and use the calc function to make sure they're exactly right. So that's pretty much a simple walkthrough on a basic graphical interface for the TI-84. Okay. Type your stuff into your Ys. You can type as many functions as you want in here. Typically, we don't do more than 3 functions at a time. Most of the time, it's either 1 or 2 functions. It's very rare you even see 3 functions all at one time. But you can type these in your Y1s, your Y2s, your Y3s, whatnot. You know how to kind of work your zooms now. Like I said, zoom in, zoom out, zoom standard, and zoom fit are the primary ones we use. We do use a little bit of zoom stat if you get into stats classes. You can trace your functions, you can graph your functions, you can look at the table of your graph for your functions, you can calculate different things on the functions that you have, whether it be specific x values, zeros, minimums, maximums, and intersection points of 2 graphs together. It's all there and able for you to do on your calculator. Okay, so I hope this helps as a little small introduction on how to graph on your graphing calculator, so that when you go into your classes, you won't be as intimidated by using this new machine. Y'all take care, and I will see you next lecture.